What's important is to understand the speed of light versus sound. Sound travels at approximately 343 miles per second. So for sound to leave Earth and travel as far as the moon, it would take approximately 696 seconds or 11.6 minutes versus that of light. Light travels at approximately 186,282 miles per second. So for it to travel from Earth to the moon, same distance as the sound traveled, it would only take approximately 1.28 seconds. That's to be understood that sunlight coming from the sun back to the Earth, it takes approximately 8.3 minutes for that sun to travel. But understand that the sun is 93 million miles away, so that's a very small amount of time that it takes to travel that distance. One of the things that's probably the most understandable is if you've been caught in a lightning and thunderstorm. You will often see the bolt of lightning and then followed by the sound of the thunder 1 or 2 seconds later. Once again, light travels faster than sound, so sound will be lagging behind. Another example of sound and light would be a fireworks display. Fireworks display, you'll notice that you'll watch a beautiful fireworks in the air, and once it goes up, you'll see the light first, and then it follows right behind it with the booming sound of the actual explosions. The next subject is persistence of vision. A chemical property of the human eye allows the eye to see moving objects approximately 24 times a second. The United States has all of their electrical fixtures running at 60 cycles a second. We look at a light that you've turned on, and it appears that it is on continuously. In reality, it is flashing 60 times a second. So when we see a circle of light, just like in this summertime when the kids take a sparkler in 4th of July and wave it in the circle, it appears that there's a complete circle going, and in reality it's just a single light moving very quickly. What you're seeing is 24 cycles per second. That's what the human eye can see. In reality, if we go to 60 cycles, it appears that we have a solid light on continuously. In reality, it is blinking 60 times a second. Continuing with the persistence of vision, note that there's a single laser dot on the board. As the dot starts to turn, we still can see it because it's at 24 revolutions a second. But as this turns to the full 60 cycles, you'll notice that the circle starts to look like it's complete. And that's because our eye cannot keep up with that speed. For further information and explanation, go to your Harper College ELT 135 Optics and Sensors book and read pages 19 through 23. Next, we'll look at the electromagnetic color spectrum that the human eye can see and cannot see. Colors blue, green, yellow, orange, and red are visible to the human eye. The last bulb, which you'll notice, which looks like it is not lit, is in fact operating, but it is infrared, so consequently it's beyond the eye spectrum. The light as shown is considered white light, and it is traveling at 60 cycles per second. So we see only but the white color light. Notice that these set of glasses sitting alongside are called diffraction glasses, and when we view it through that, you will see the color spectrum. Note, when looking through the diffraction glasses, the same light appears as a rainbow. This is the same colors that you would see as sunlight passes through your house windows, and sometimes we'll put a slight rainbow on the floor or on the wall.